Today we're going to be talking about compound inequalities, and then we're going to be graphing them. Okay. We've dealt with single inequalities, something like this, and a multi-step one like this one. But now we're going to be dealing with compound, or more than one, using and and ors. And we're going to see how those kind of look. Something to keep in mind, though, as we're going through with these, if we're dealing with the case that it's an and, remember it has to work for one and it has to work for the other one. It has to work for both. If it's a case, let's say this were an or, then our answer could either be in this one or it could be in the other one. It doesn't have to be in both. Okay, so a good first step is to kind of solve both of these like we did before, and then we'll see what happens. So for this guy here, I can subtract 4 from each side. So I have 2x less than or equal to, 4. Divide by 2. X is less than or equal to 2. And we keep the and. Sure, it's really important. Bring that down. Then this one's nice and easy. Add 5. So x, well actually, for you guys I'll do it in different colors. X is greater than or equal to -3. So what exactly does this mean? Well, our x value, our answer, has to be less than -2 or equal to, less than or equal to 2, and at the same time it has to be greater than or equal to -3. So let's graph that. Okay. Here's 2, -3. So it has to be less than or equal to 2. Well, because of the equal to, I have a dot there. It has to be less than that. So I'm going to go to the numbers that are less than 2. And at the same time, it's greater than -3. Again, equal to, so there's a dot. And remember, we're looking for the numbers that satisfy both of these. Well, the only one that satisfies both of them is going to be this shaded region right in between. Okay? So those two lines meet, fall in love, have kids in the purple. So again, all the numbers that are inside the purple here, between -3 and 2, are the only numbers that work for this one and at the same time work for that one. If you were to pick a number out here, well, it would fail one of them, this guy. Okay? So the numbers in the purple work for both. You can even test it out. You can pick like 0, that's in between them, and you'll see that it works for that one and at the same time works for the other one. Okay, let's look at another one. Okay. This one we'll use y this time. Doesn't get much love. Okay. So now, in this case, we have an or situation. So the first thing that should be going through your mind is our answer could work for this one, or it could work for that one. It doesn't have to work for both. So let's do what we did before and solve each inequality. So this one I'll plus 9. So 3y is less than or equal to 21. Divide by 3. So y is less than or equal to 7. Then bring down the or. Okay, for this one here, we have a opposite y is less than or equal to -9. Remember, there's kind of like a little hidden one there. So I could divide each side by -1 because you want to get y by itself. So now you get y by itself because the -1's factor out to 1. -9 divided by -1 is 9. And remember, when you divide or multiply by a negative number, you flip the inequality sign. So we're saying y is less than or equal to 7, or y is greater than or equal to 9. Well, let's draw a graph and see what that looks like. Okay, so we have 7, we have 9. Y has to be less than or equal to 7. So all those numbers over there, and at the same, or y has to be greater than or equal to 9. So all the numbers that are greater than 9. So our answer are the numbers over here, or the numbers over here. So any number that is in this purple shaded region here, or that purple shaded region there, will work for one of these. Not both, but one. And that's all we want because it's an or. Any numbers in here don't work. Okay. Okay, let's try one more together. So 2x minus 4 is less than or equal to 4. Or x minus 9. So take a second and try to do this one by yourself, and then come back. Welcome back. Okay, first thing we should look at, this is an OR case, so that's work for this one or this one, not necessarily both. So let's do what we did before. Let's solve each one. Add 4. So 2x is less than or equal to 8. Divide by 2. X is less than or equal to 4. Bring down your OR. Add 9. X is greater than or equal to negative 9 plus 9. Oh, 0. Okay, so X is greater than or equal to 0. So I'm saying x is less than or equal to 4, or x is greater than 0. Let's graph that out and see what happens. Okay, so I'm saying x could be less than or equal to 4. So it could be anything going that way. Or x could be greater than or equal to 0. So I could have anything going that way. Now, if you remember the first example we had, the two lines met, they fell in love, and all their kids were the stuff in between. Okay? Well, that was because it was an and. It had to work for this black line and the orange line. But now we have an or. So it could work for the orange or it could work for the black. Well, if you look at the orange line, all the answers are everything right there. And it keeps going on and on and on. And the black line, all the answers are everything right there. And it keeps going on and on and on. Now remember, an or, we could be a one or the other. So it could be an orange or black. You should be looking at this and saying, well, if I could be an orange or black, this covers the entire number line. So in this case, our answer would be all real, oops, that was terrible, numbers. But Mr. Pons, what does that mean? Good question. Okay, we're saying our answer is all real numbers. So what exactly does that even mean? Well, it means that we could take any x value, any at all, any in the world, and it would work for this one, or it's going to work for that one. Any x value at all will make one of these true. If you don't believe me, pick any number you want and see. Spend the rest of your life trying to find one. You won't. So again, all this means is that we can pick any x value and it would work for one or the other. We're not saying it's going to work for both, because then that'd be an and. It'll work for one or the other. Okay? Hopefully this makes a little bit more sense, and thank you very much.